Hi, Honors Algebra 2 students. Today we're going to be looking at the Chapter 4 Day 3 notes, which are focusing on graphing compound inequalities on number lines. Before we get started with specific examples, I want to draw your attention to what I have written at the top of the note sheet. So when we graph compound inequalities, we're going to have some critical values, and at those values we need to determine if we're going to graph those critical values as an open circle or a closed circle. So if we have a less than symbol or a greater than symbol, we'll graph that critical value with an open circle. If we have a less than or equal to or greater than or equal to symbol, we'll graph those critical values with a closed circle. And then the next thing I want to mention is that in these compound inequalities, at least in some of them, you'll see either the word or the word and. When we see the word or, it means as long as a value satisfies either one of the inequalities or the other, we'll include it in our final answer. If we have a and compound inequality, a value would have to work in both of the inequalities within the compound inequality in order for it to be in our final solution. In other words, it'll be where those inequalities overlap. And then finally, what I have written to the right, that focuses on some set notation that we're going to do at the end. This symbol right here means union, so that corresponds to the word or if we were writing it with an actual word instead of a symbol. And then this symbol right here stands for the intersection of, and that corresponds to the word and in a compound inequality. All right, so let's get started with some specific examples. You're going to see me graph an and compound inequality, which we have in our first example right here, by kind of building our way to our solution. So I'm going to start by graphing each one of the inequalities above the number line, and then we'll transfer our final answer onto the actual number line. But first things first, I ask you to put 0 on your number lines because that gives us a foundation for everything else. So I do expect your number lines to have 0 on them. And then we've got something going on here at 2 in one of the inequalities and at -1 in the other inequality. If you're working with smaller numbers, you can just have the tick marks represent units of 1. If you're working with larger numbers in any of the inequalities, you can scale by something different. So you could scale by 2s or 3s or 5s or 10s or whatever is appropriate. Okay, so in the first inequality, x is greater than or equal to -1. We're going to do a closed circle at -1 because we have a greater than or equal to symbol. And then any of the values that are greater than or equal to -1 are to the right of -1. And then if I take the second inequality, x is less than 2, I'm going to have an open circle at 2 because it's a less than symbol, not a less than or equal to. And then any of the values that are less than 2 are shaded to the left of 2. Now, as I mentioned earlier, an and compound inequality has to include values of x such that they work in both of the inequalities, or in other words, from a graphing perspective, visual perspective, it's where these overlap. It's where these two graphs overlap that we just did. So if we kind of take our areas where those overlap and transfer them down to our final number line, we're going to have a closed circle at -1, an open circle at 2, and we're going to shade everything in between. And those represent all of the x values that satisfy both of those inequalities. So for instance, if you pick the value of 0, 0 is I keep saying less than, 0 is greater than or equal to -1, and it's also less than 2. And that would work for any of the values that are in that shaded region. All right, next example. Notice we have the word or in our compound inequality. Most of the time for ors, I just put those directly on the number line because anything that works in either one inequality or the other will be in my final solution. So let's put 0 on our number line, and then that also happens to be one of our critical values, and then we've got another critical value of -2. So x is less than -2. I'll have an open circle at -2 shaded to the left. That represents all the values that are less than -2. And then at 0, I'm going to graph a closed circle because it's x is greater than or equal to 0, and then I'm going to shade everything to the right. Those are the values that indeed represent anything greater than or equal to 0. And that's going to be my final solution. So any number that I would pick that's in that shaded region would work in either one inequality or the other. All right, in the next example, we've got another and compound inequality. So let's put 0 on our number line, let's put 2 on our number line, and let's put -3. And notice I'm letting each one of those tick marks represent a unit of 1, but I'm just labeling the critical values. If you want to label every single little tick mark, that's fine. All right, x is less than -3, so at -3 I'm going to have an open circle, and I'm going to shade to the left. And then at x is greater than or equal to 2, I'm going to have a closed circle shaded to the right. Now, for an and compound inequality, I need where those overlap. And as you can see, those two simple inequalities that make up the compound inequality, those do not overlap in any area. So my final answer is going to be a blank number line, because there would be no solution. But usually what I do, I ask students to write the words no solution or use the mathematical symbol, because I want to make sure that you didn't just forget to graph something on the number line. All right, next example. We have an OR compound inequality. I am going to start by graphing this one above the number line, and I think you'll see why in just a moment. So I'm going to put 0 on the number line. Notice 0 doesn't have to be perfectly in the middle. All right, you can adjust it according to the values that you've been given. X is less than or equal to 2. I've got a closed circle at +2 shaded to the left. X is greater than -4, open circle at -4, shaded to the right. Now again, keep in mind for an OR compound inequality, as long as a value works in either one inequality or the other, either one, it will be in our final solution. So our final solution for this particular example is everything on the number line. And also, notice I'm putting arrows on the end, and I've done that on the second example as well. I had arrows on the end because it does keep going forever. So every single value on the number line would either be less than or equal to 2, or it would be greater than -4. And then again, we could use the mathematical symbol just for all real numbers just to clarify that. But for sure, you should have a number line where everything is graphed. Actually, I should say where everything is shaded. All right, for our next examples, we'll start to use that set notation that I was talking about. So let's take things out of this set notation, but let's first read it. So this is read x such that x is greater than or equal to -1. I'm going to intersect that with x such that x is less than 3. So let's write that kind of similar to how the things above, the examples above were written. So this would be x greater than or equal to -1. Intersection we'll replace with the word and. X is less than 3. All right, so let's put 0 on our number line, and then we've got +3, and then we've got -1. We'll do a closed circle at -1 because it's greater than or equal to, and then I'm going to shade to the right to represent the values that are greater than or equal to -1. And then open circle at +3, shaded to the left, that represents the values that are less than 3. And then again, where these overlap for our final shaded region on our number line, we'll have a closed circle at -1, an open circle at 3, and everything shaded in between. All right, our next example, once again, let's write it out of set notation, but first things first, this is read x such that x is less than 0, joined with or the union of x such that x is greater than 4. So let's write that similar to the ones above. X is less than 0, union is replaced with the word or, x is greater than 4. So 0 is on our number line, 4 is on our number line. We'll have an open circle at 0 shaded to the left. Those represent the values that are less than 0. And then we'll have an open circle at 4 shaded to the right. Those represent the x values that are greater than 4. All right, in the next example, we have to do a little solving first. So if we solve the inequality on the left, we'll subtract the 2x from both sides, and we'll get 1 is greater than 0. And if you think about it, our variables went away. 1 is greater than 0. That's a true statement. So our final answer for our inequality on the left is all real numbers. And then if we solve our inequality on the right, add 2 to both sides, divide by 3, we get x is less than 3. And then we have to bring down the word and, since that was in our original compound inequality. So all real numbers obviously would be everything on the number line, and then x is less than 3 would be an open circle at 3, and then everything shaded to the left. Again, for an and compound inequality, we need where those overlap. So where those overlap, or what's included in both inequalities, that would be a solution, would be an open circle at 3 and everything shaded to the left. That represents all the values that would work in the first inequality as well as working in the second inequality. And then for the last example, x such that x is not greater than negative 2. Well, if x is not greater than negative 2, that means x is less than or equal to negative 2. So again, we'll put 0 on our number line, we'll put negative 2 on our number line, we'll have a closed circle at negative 2 because it's less than or equal to, and then we will be shading to the left. And again, anything in that shaded region would represent a number that is less than or equal to negative 2, which also means they are values that are not greater than negative 2.